Good morning. Thanks for joining me for this session on dynamic workload fingerprint generation. My name is Ananth Narayan. I work at Intel, and we also had Mritika Ganguly working with me on this. So in a typical cloud, the cloud consumer is looking for the best performance for their workloads. However, the cloud provider is looking for efficient utilization of the infrastructure. And these tend to be conflicting requirements, and the best that one can do is to provide predictable performance for the workloads that are running on the cloud. Now, the problem, however, for the cloud provider is that they do not have any information on how the workload is going to behave. So either they need to instrument the workload or ask the customer to provide all this information about how the workload is going to behave. However, one really can't trust the customer, and of course, there are complex interactions and patterns might change over time. So what do? The solution for this is to be able to dynamically detect how the workload behaves over time. This doesn't require instrumentation. There's no dependency on the customer to give us some information. It captures the complex time-varying behavior and, of course, interactions between workloads that are running simultaneously. So in order to do this, we first break down a workload into a sequence of phases, where a phase is a discontinuity in time, where the workload makes a measurable system impact. And from this sequence of phases, one can come up with a phase residency and a phase transition matrices, which we call the workload fingerprint. So we did this work on dynamic fingerprint generation with OpenStack with a simple compute monitoring agent on the compute host. The workload fingerprinting was implemented within Watcher as a fingerprinting strategy, and finally we have a heat map to visualize the whole thing. So let me in terms of the metrics, all the metrics that we used for doing the fingerprinting were metrics that were exposed by libvirt, and there was nothing custom with respect to the platform or the hardware. So let me just show you a video of how we go ahead and do it. So once we run the workload fingerprinting algorithm in the background, so the fingerprint gets stored and it starts to show up in Horizon. And if you see, this is a phase transition probability graph, which shows you in a heat map form what's the transition probability from the current phase to the next phase or to any other phase. Now, this is generated for each workload that is running on a compute host, and is done for all the compute hosts that are part of the cluster. Further, what we also have is a phase sequence, which goes ahead and captures how the workload behaves over time. So if you see here, you can actually see that there are two workloads that are being shown. There's one in blue and one in brown. And the blue one is kind of following a certain series of phases, but the brown one kind of jumps up and down. That allows us to identify points where the two workloads are in conflicting requirements, potentially take some sort of remedial action to address performance issues. So what next? So once we have this knowledge of the fingerprint, what we would like to do is to take this information to do resource management, influence scheduling decisions, manage load balancing, which includes migration in a regular cluster, in a standard OpenStack cluster, or if you have pooled infrastructure, you can potentially use steps such as dynamic composition and provisioning of your resources to add capacity into your rack, and then go ahead and work with the new, to the expanded rack. So composition and provisioning of pooled infrastructure is supported by Intel Rack Scale Design. Feel free to drop in at the booth to talk more. So if you are interested, we're going to release the code in Watcher GitHub. The BPs related to various actions are work in progress. And if you have any more questions, feel free to contact me at my Launchpad at 8. Thank you.